Hello, my dear students. I welcome you all to KLS Gokte PU College of Commerce and Science, Belgavi. This is our lecture number first on a topic hydrocarbon. This topic belongs from organic chemistry. This is Mr. Akash Vasan Nesarkar, lecturer in chemistry, Department of Chemistry. The topic hydrocarbons. Hydrocarbon, the name itself gives the meaning, where the word hydro stand for hydrogen atom and the carbon stand for carbon atom. It is nothing but the compounds which contains carbon and hydrogen atoms. Such compounds are called hydrocarbon. For example, CH4. What is the name of this molecule? Methane. Yes, you are right. Methane is an hydrocarbon. Next, C2H6. What is the name of this molecule? Sorry, C2H4. Yes, it is ethene. This is also what? Hydrocarbon, because it contains the carbon and hydrogen are the only main elements, and therefore if the compounds contains only carbon and hydrogen, then such compounds are called hydrocarbons. So did you understand? Okay. Now, what are the things we are going to learn in this topic? The key concepts are, first of all, let us try to know the classification of hydrocarbons. Based on what the hydrocarbons are classified, that we are going to study. Next, we will deeply study about alkanes and also alkenes and alkynes. Also, the aromatic hydrocarbons, which are known as arenes. Next, benzene and carcinogenicity and toxicity. Okay, so let us know the classification of hydrocarbon. As I said, that hydrocarbons are nothing but what? Compounds containing carbon and hydrogen elements. Now hydrocarbons are classified into two types. Okay, so it is mainly classified into two types. The first one is open chain compound. First one is what? Open chain compound, which is also called as a aliphatic compound. See, open chain compound is nothing but they are not going to form a ring like this. Okay, they are not going to form a benzene ring or any ring, cyclobutane. So ring formation does not take place in aliphatic compound. The aliphatic compounds are nothing but what? It is open chain compound, means no formation of ring take place. And second one, a cyclic compound. Cyclic compound means what? A ring formation take place. It may be cyclohexane, it may be cyclotrihexane, and etc. Okay, again the aliphatic compounds are further classified into two types. First one is a saturated hydrocarbon and second one is a unsaturated hydrocarbon. You know very well about that saturated hydrocarbon. The saturated hydrocarbon is a hydrocarbon which contains carbon-carbon single bond or carbon-hydrogen single bond, right? Am I right? Carbon-carbon single bond and carbon-hydrogen single bond. For example, alkane is a saturated hydrocarbon. The word saturated stands for what? It should have the carbon-carbon single bond or carbon-hydrogen double bond. The example is alkane. So alkane example, for example, CH4, methane, okay, C2H6, ethane, okay, propane, butane, pentane. These all are what? Saturated hydrocarbon. Okay, or we can say these all are alkane. So the word alkane, A-N-E. Remember, if any molecule's name end with the ANE, then it is a saturated hydrocarbon. For example, methane. So it is ends with ANE. ANE is nothing but what? Saturated hydrocarbon. So it should have carbon hydrogen single bond and carbon carbon also single bond. Okay, so such type of compounds where the carbon carbon single bond and carbon hydrogen single bond is present, such compounds are called as a saturated hydrocarbon. And the example is alkane, that is methane, ethane, propane, butane. And the saturated hydrocarbon having the formula, that is general formula, we can say general formula CnH2n plus 2. And about this formula we have already discussed in our previous unit, right? Yes students. Okay, now the second one is what? Unsaturated one. The unsaturated hydrocarbons are further classified into two types, alkene and alkyne. Now let us try to understand what is unsaturation. Unsaturation means the compound should contain the carbon-carbon double bond or carbon-carbon triple bond. Okay, suppose if contains single bond, then it is saturated one. Suppose if it is having the double bond or triple bond, then it is an unsaturated hydrocarbon. Is this clear to you? Yes, students. If the compound contains carbon-carbon double bond or carbon-carbon triple bond, then it is unsaturated hydrocarbon. Then it is unsaturated hydrocarbon. Okay. This unsaturated hydrocarbon is further classified into two types. First one is what? Yes. First one is alkene, and the second one is what? Alkyne. Alkene, Alkene. Alkene. ENE stand for what? The carbon-carbon contains double bond. If the compounds containing carbon-carbon double bond, then it is alkene. Then it is what? Alkene. For example, C2H4. This is what? Ethene. This is what? Ethene. So this contains carbon-carbon double bond like this. So this is your ethene. H. So this is your ethene, where carbon-carbon contains double bond. So alkene is the compound which contains carbon-carbon double bond, and it is having the formula, that is general formula CnH2n. We know about the general formula because it is already over in last one. Next one is what? Alkyne. Alkyne is an unsaturated hydrocarbon which contains carbon-carbon what? Triple bond. Which contains carbon-carbon triple bond. And this is an example of alkyne, that is what? Ethyne, right? So this name is what? Yne, with Yne. If Yne is there, then it should have the triple bond. So alkene and the alkynes are unsaturated hydrocarbon which contains carbon-carbon double bond and carbon-carbon triple bond. If the compound contains carbon-carbon double bond, then it is alkane. If it contains carbon-carbon triple bond, then it is alkyne. And if it is contains only carbon-carbon single bond, then it is alkane. Is this clear to you, students? Yes, it is very simple. Try to remember the examples of each. Saturated hydrocarbon, it is alkane. Example is methane. General formula CnH2n plus 2. Okay. And unsaturated hydrocarbon, it is alkene, having the formula CnH2n. Example is ethene. And next one is unsaturated hydrocarbon alkyne, having the formula CnH2n minus 2. So this is about open chain compounds, that is called as a aliphatic compounds. Yes. Okay, fine. Now next one is what? The second type of hydrocarbon is what? Cyclic compounds. It is what? Cyclic compounds. The cyclic compound means what? The formation of cycle or ring take place. So cyclic compounds are classified into two types. First one is aromatic, means it should have, yes, it is already over guys, benzene ring. It should have what? Benzene ring, right? And alicyclic compound means what? It is alic ring made up of only same number of atoms, that is cyclobutane, cyclopentane, number of atoms, that is carbon, hydrogen. Such type of compounds are called alicyclic compound. Next one, what? Benzenoids. These are the compound should contains at least one benzene ring, or the compound should contains at least one benzene ring, are known as benzenoid compounds. Non-benzenoids, this compound should not contain the benzene ring, that is called as a non-benzenoid. This classification we have already discussed in deep about the previous unit, right? And this is a just a revision of that. Hydrocarbons, open cyclic compounds, saturated, unsaturated, aromatic, alicyclic, benzenoid, non-benzenoid. Remember the examples of aromatic compound, benzene and toluene. Alicyclic compound, cyclobutane. This is your cyclobutane. This is your cyclopropane. This is your cyclopentane. So this is all or what? Alicyclic compound. Benzenoids, okay, remember it should contain what? Benzene ring. Non-benzenoid, it should not contain the benzene ring. Okay, next let us try to understand first alkanes. Okay, here we are going to discuss more about only alkanes. Alkanes are nothing but what? The compound should contain carbon-carbon single bond and having the general formula CnH2n plus 2. Is that clear? Okay. Alkanes are saturated open chain hydrocarbons containing carbon-carbon single bond. Example, methane, ethane, propane. Right? These hydrocarbons are inert under normal condition. Inert means what? At a normal condition, they do not show any reactivity with other elements, molecules, or compounds. So if they are not showing any reactivity, then it is called as the inert. Okay, समझ में आ रहा है? So वो react नहीं करते. So जब एलिमेंट रिएक्ट नहीं करता तो उसको हम क्या कहते हैं? इनर्ट. एलिमेंट और मॉलिक्यूल जब रिएक्ट नहीं करता अंडर नॉर्मल कंडीशन, तो उसको हम क्या कहते हैं? इनर्ट. ट्राई टू अंडरस्टैंड द meaning of inert. Inert is nothing but what? It do not show the reactivity. The hydrocarbons are inert under normal condition. Means what? At a normal condition they do not show any reactivity. That is, do not react with acid, bases and other reagent. Okay, is this clear? Okay. Hence they were earlier known as a paraffins. Therefore they are called as a paraffins. The para means little affinity, means they were showing the very little affinity, therefore they were called as the paraffins. Alkenes exhibit chain isomerism, position isomerism and conformational isomerism. So alkenes can show three types of isomerism: chain isomerism, position isomerism and conformational isomerism. Yes, so this is about the alkanes. What we have learned in this segment: alkanes are saturated one, first of all, having the formula CnH2n plus 2. These are open chain hydrocarbon which contains carbon-carbon single bond. Example, remember methane, ethane, propane. These alkanes are inert under normal condition, means they do not show any reactivity with the acid, bases and etc. Therefore they called as a paraffins. The meaning of paraffins is nothing but what? Little affinity. Okay, and also the alkane exhibit isomerism such as a position isomerism, chain isomerism and conformational isomerism. So these are the three types of isomerism can be shown by the alkenes. Now let us try to understand physical properties of alkenes. See, this is very important. Try to remember the properties of alkenes. The first one, the first four members, that is methane, ethane, propane and butane, are colorless gases. So the early members of the alkanes are what? Gases. The next 13 members are colorless liquids. So next 13 members are what? Liquids. And the always higher members of alkanes are what? Solids. Higher members of alkanes are what? Solid. So this is the first physical property you have to remember. The second one, the boiling point of alkanes decreases on branching. Van der Waals force decreases. As a van der Waals force what? Decreases. Means as the branching increases, the boiling point decreases because van der Waals force decreases. Third one, alkanes with an even number of carbon atoms have higher melting points as compared to the next higher or lower alkanes with an odd number of carbon atoms. So if even number of carbon atoms are present in alkanes, then they will have the higher melting point as compared to next higher or lower alkanes with the odd number of carbon atoms. So if it is having odd number of carbon atoms, their melting point is low. Fourth one, alkanes being a non-polar in nature, soluble in non-polar solvent but insoluble in polar solvents such as water. So alkanes are what? Non-polar, and water is what? Polar one. So non-polar always insoluble in polar one, therefore alkanes are insoluble in water. Okay, why it is so? Because alkanes are what? Non-polar one, they do not show any polarity and therefore it is insoluble in water. Now let us see the first four members of the alkanes. Okay, so this is your general formula CnH2n plus 2. So CH4 is nothing but what? Methane. C2H6 is nothing but what? Ethane. C3H8 is nothing but what? Propane. And C4H10 is what? Butane. So this is about alkane. Okay, properties are what? The first three members or four members are colorless gas, next 13 members are liquids, and next higher members are what? Solids. Boiling point decreases as branching increases because van der Waals force decreases. Alkanes with an even number of carbon atoms have higher melting point than that of odd number of carbon atoms. And fourth one, alkanes are insoluble in water because alkanes are non-polar and other water is what? Polar one. So non-polar, insoluble in polar solvent. Is that clear? Okay. Now, so preparation of alkenes. Preparation of what? So it should be alkane. Preparation of what? Alkane. So we can prepare the alkane by using the various reagent and also with the different reactants. So left hand side what we will have? The reactant, and arrow mark what we will have? The reagents. So whatever present on the arrow mark we call it is as a reagent, and left hand side it is called as a reactants. Okay, so right hand side what we get? The product. Okay, so reactants react with the reagent gives product. So product should be what? Alkane, because we have to prepare the alkanes, and the preparation of alkane can be done by using the various reagent and the various reactant. The very first one is what? CH3COONA, that is sodium acetate. It is also called as a sodium salt of carboxylic acid. So when it is react with the soda lime, that is a mixture of sodium hydroxide and calcium oxide, it form what? Methane. It form what? Methane. So when sodium acetate reacts with soda lime, it gives methane. So this is the first preparation you have to remember. The second one, aluminum carbide. When aluminum carbide reacts with the water, it gives methane. It gives what? Methane. Here we are not going to focus on the byproduct. Okay, byproduct let us study later on. Next, methyl magnesium iodide. This is your Grignard reagent, that is called as a RMgX. What is Grignard reagent? Okay, the Grignard reagent is alkyl magnesium halide. R stand for alkyl, Mg stand for magnesium, and X stand for what? Halides. So alkyl magnesium halides are what? Grignard reagent. So when Grignard reagent reacts with warm water, it gives what? Methane. It gives methane. So from the Grignard reagent also we can prepare alkane. From sodium acetate also we can prepare alkane, and aluminum carbide also we can prepare alkane, but by using different reagent. With sodium acetate reacts with the soda lime, it gives methane. Aluminum carbide reacts with the water, it gives methane, and Grignard reagent reacts with the warm water, gives methane. So methane is what? Your hydrocarbon. The very next reaction is what? Fourth one, that is carbon monoxide. When reacts with the 3 moles of hydrogen in the presence of nickel catalyst at 300 degrees Celsius, it gives methane. So here we are doing the addition of hydrogen in the presence of nickel, therefore it is called as a hydrogenation reaction. Sometimes it is also called as a hydrogenation. Hydrogenation is nothing but what? Addition of hydrogen, and this reaction take place at a 300 degrees Celsius in the presence of the catalyst nickel, Ni. Do not write Ni2, just consider only Ni. Okay, so nickel is what? A catalyst. Now let us know what is the function of a catalyst, or what is the role of the catalyst. See, if the reaction is slow, then to increase the rate of the reaction we require what? Catalyst. And suppose if the reaction is a fast, and if you want to make the reaction slower, then also we can use a catalyst. So the role of the catalyst is nothing but it will increase the rate of the reaction, or it may decrease the rate of the reaction without affecting the reaction. So that is the role of the catalyst. Okay, it will remain as it is after the completion of the reaction. Now when carbon reacts with the 2 moles of hydrogen in the electric arc at 1200 degrees Celsius, it form methane. It form what? Methane. Next one, methyl iodide. When reacts with a zinc and copper and methanol and 2 moles of hydrogen atom, it gives methane. So all these reaction gives what? The hydrocarbon methane. Even this, when methyl halide reacts with the nascent hydrogen, then it gives methane. It gives what? Methane. And next one, what? Methanol, that is CH3OH, methyl alcohol. When reacts with the 2 moles of hydrogen in the presence of red phosphorus at 150 degrees Celsius, it form what? Methane. So these all reaction form the hydrocarbon methane, that is CH4. Okay, so these all reaction gives the product of hydrocarbon, where carbon hydrogen single bond is present. So try to remember the preparation of any 4 reaction, or any 1 reaction, or any 2 reaction, how much it is possible for you. So try to remember at least 2-3 reactions for the preparation of hydrocarbons such as a methane. So here the role of the reagent is also important and the reactant is also important. Now, so preparation of alkanes, so these preparations we'll study in our next class. Okay, thank you.